Okay, and this is homework 6, and let's talk about problem 1. We know that x and y have joint density function. X plus 1 plus xy over a. It is valid when xy in this range, and it is 0 in otherwise. So first find a so that the above defined is a valid joint density function. So we know that xy have range. So from -1 to 1, it should equals 1. It is the joint density function is 1 plus xy over a dx dy, and it equals for x, we know 1 over a equals a over 1 over ax from -1 to 1, and plus for xy over a, it is y over 2a multiply x to the power 2 from -1 to 1 dy. So we can see that this is an even function. So from -1 to 1, it equals to 0, and so it equals from -1 to 1, and this part equals 2 over a dy, and it equals 4 over a equal 1. So we can have a equals 4. Second, xy anchor related. Show my answer. Then we can find the expect of xy. So expect x minus x multiply y equals from -1 to 1 xy, and we should time the joint density function equals over a dx dy, and this is and we know that a equals 4, so this is 1 over 4, and we can divide them into parts. One part is xy dx dy, and another part is x to the power 2 times y to the power 2 dx dy. For the first part, it equals y over 2 x to the power 2 from -1 to 1 dy, plus for the second part is y to the power 2 over 3 multiply x to the power 3 dy, and from -1 to 1. So we can see that for the first part, the x to the power 2 is an even function. So from -1 to 1, it equals to it equals 0. So we can only calculate the second part. It equals 1/4 multiply minus 1 to 1 dy, and it equals 1/4 multiply 4/9. It equals 1/9. So now we have the expect of x multiply y. It is 1/9. And now we should to calculate the expect of x. It equals still from minus 1 to 1 x times the joint density function dx dy equals we can still divide them into two parts. And this is the first part, and the second part should be x to the power 2 times y. So we can see this part become x to the power 2 from minus 1 to 1. It's a even function. So this part equals 0. And for this part, this becomes 1/3x to the power 3 from minus 1 to 1. So the whole part equals to 2/3, and we should multiply the time y, and the time y, then it becomes y to the power 2. So it also a even function. So we can see the first part and the second part both equals 0, so the expect of x equals to 0. Now we know that the expect of x times y equals to 1/9, and the expect of x equals to 0, and we can get the conclusion directly that the expect of xy doesn't equal the expect of x equals the expect of y. So that we can see that they are not uncorrelated. And we also can see that they are not independent. So that's the problem 2 and problem 3. And for the question 4, we should find the joint density function of x to the power 2 and y to the power 2. Now we let z equals x to the power 2 and w equals to the y to the power 2. And now we have equals we have this, and I equals 1, 2, 3, 4, and that is only for z from 0 to 1 and w from 0 to 1. So for this range, we can find that the joint density function equals J1 plus fxy minus w over J2 plus fxy z minus w J3. And the last one, and this is equals plus. So and we can get this part is like this. So this is the density function, the joint density function of z and w. Yeah, and this is a joint function of x to the power 2 and y to the power 2. So now, and for the question 5, if we want to prove or disprove that x to the power 2 and y to the power 2 are independent, we should find the density function of fz is the density function of x to the power 2, and it equals from negative infinity to positive infinity dw. So we have the range of z and w. So it is from 0 to 1. So we can see it's only this is equals from 0 to 1. So the density function of z, it equals this, and we can easily get that the function of w, it equals this. So for the answer of question 4, we can get that the joint density of z and w equals the density function of z multiply the density function of w. So we can see z, w are independent. And z equals x to the power 2 and w equals y to the power 2. So x to the power 2 and y to the power 2 are independent.